Okay, hi guys. So this is parts E, F, G, and H for still the same question, 2019, question 1. And we're going to start off with question E. And question E reads, the equipment shown above is provided so that the student can determine the value of molar heat of solution of urea. Knowing that the specific heat of the solution is 4.18 joules over grams per degree Celsius, list the specific measurements that are required to be made during the experiment. So they want us to find molar heat of solution for urea, right? And that's basically the molar heat absorbed or released when 1 mole of the substance is dissolved in water. And every time we're solving for heat absorbed or release, we use Q, right? So the specific measurements that we would need when if we were to solve this are, we would start with like initial temp and the final temp, right? Temperature. When we're looking for change in temperature for Q. And then the others that we would need would be the mass of the water and also the mass of the urea. You would need the mass of the water, mass of the urea, and then the initial temperature and final temperature in order to find for the molar heat of solution for urea. And for these, you'll get 1 point for stating initial and final temperatures, and you'll get 1 point for stating the masses that you would need in order to find the molar heat of solution for urea. That's 2 points total for part E, right? And then part F would be the next part. And part F reads, the entropy change for the dissolution of urea is 70.1 joules over moles per Kelvin at 25 degrees Celsius. Use the information in the table to calculate the absolute molar entropy of delta S. So the table shows us this compound is solid, and they say it's 104.6 delta S, and then the other one is unknown for the same compound, aqueous. And so we're finding for what would be the delta S for the urea molecule in an aqueous solution. And so if we were to just draw what they're asking for without plugging in any numbers, that would be the delta S for aqueous minus delta S for it's solid, right? So this is given, and this is given, and this is what we would be finding for X. So minus 104.6 joules over moles, okay, equals 70.1 joules over moles times K, right? And then we're to add this, 6. This is equal to 174.7 joules over moles times K. And that is also same thing as delta S for H2NCO and H2, the urea, as an aqueous. And you would only get 1 point for the right answer for this question, for this part of the question. Next, we have part G. And G asks, using the particle level reasoning, explain why delta S is positive for the dissolution of urea in water. So urea start as a solid, and then in water it's aqueous. Why would delta S be more positive? So we know when the particles in a solid compound are very compact. However, if it's in water, the particles would be more separated, right? More dispersed. And so delta S, which is like measures disorder within the particles, will be positive because disorder increased. So this right here would only earn you 1 point for your correct answer. So either, yeah, just correct answer justification, 1 point only. The next part would be the last part of this question, which is part H, right? So part H reads, the student claims that delta S for the process contributes to the thermodynamic favorability of the dissolution of urea at 25 degrees Celsius. Use the thermodynamic information above to support the student's claim. Okay, so they're asking if delta S, does the value of delta S make this entire reaction favorable? So every time we look at these type of questions, we always use this equation, T delta S, because these altogether contribute to the total value of delta G. However, delta S here is positive, right? So value of H minus times the temperature that you have times delta S, because delta S is positive and you're taking away this large positive number from the given H value that we have, the delta S value that we have in this in this given problem is gonna keep making delta G smaller, so more negative, and the more negative delta G is, the more favorable the reaction would be. And so for this part of the question, you would only earn 1 point for your correct answer. That's it.